So, today's polynomial function 6-2. We'll spend today and tomorrow on this, and then you have a quiz on Wednesday. We'll go one day of 6-3, and then you guys have break. We'll come back. We'll spend about a week working on chapter 6, take a test, then we'll have final exam review and final exams. That's kind of the end of this. That's the semester. So some of you are doing really great with keeping up. Some of you not so much. So if you aren't, make sure you're trying to get yourself caught up here. All right. Parts of polynomial function. Knowing that this thing right here that's attached to your variable with the greatest term is called your leading coefficient. You'll see that terminology, especially when you're reading textbooks. Talk about the leading coefficient. This thing attached to the variable with the largest degree. Now, when I say degree, I'm talking about the power. So this has a power of 1 for linear, power of 2 for quadratic, so third power is cubic. Okay, this whole thing here is called a polynomial. Okay, so we classify polynomials based upon their degree, their highest degree. So what degree is this polynomial?
Third degree.
Third degree. This is the third degree because the highest degree is 3. Okay. Questions? All right. Page 261 of your text, if you were using your text to follow along, but that's where this information comes from. Okay, standard form is when all terms have been combined and put in order by degree, from greatest to smallest. Okay? Making sure you understand what standard form is. So you've combined all like terms, put in order from degree, or by degree from greatest to smallest. All right? Based on that, I want you to write those two polynomials in standard form. Okay, here we go. Okay, how many got negative 3x plus 5? All right.
This girl.
Okay. And here it looks like we could put together the x cubed, so 5x cubed plus x squared. All right. And minus 4x. So, how many got that? Any questions on it? All right. What's the degree of each of those? Go ahead and tell your neighbor there.
Third, second, first.
Okay, so degree here is? Volunteer. Yeah.
First degree.
First degree. What's another name for first degree?
Linear.
Linear. Okay? First degree, also known as linear. What's degree is this one, Jaden? What do you got? Third degree. And you know what we call third degree?
Cubic.
That's actually 3 terms. This is called a cubic. Yeah.
Would that be part of the answer?
Cubic. Third degree. We usually, with the first degree, second degree, and third degree, we have special names we use. So you'd want to call this one linear, this one cubic. Okay? In fact, those special names are on a table on page 262. They're also right here. Okay, we will be classifying based upon degree and then based upon name. Okay? Or excuse me, based upon number of terms. So there's our classification based upon degree. Here's our classification based upon the number of terms. So for instance, if you're given this polynomial right here, the 6. The 6 is a 0 degree because it doesn't have a variable. We call that a constant. That's its classification by degree. We use this term, constant. It has one term, and one term, mono means one, so it's called a monomial. Whereas since there are 2 terms here, there's an addition sign in between, so 1, 2 terms. A 2 terms is called a binomial, bi meaning 2. Okay, since its highest degree, if you don't see a power, it's 1. Since its highest degree is 1, x to the first, we call that linear. Okay, once again, we want to use these terms. In the polynomial 3x squared, where its highest degree is 2, that is called a quadratic. We're pretty familiar with those. 3x squared is only one term, so there's one term there. We call that, once again, a monomial. Notice the x squared and the 3, they're attached with multiplication, so that means it's only one term. If there's an addition sign in between, then there would be more terms. And then if there are 3 terms, notice we got subtraction signs in between, 3 terms, so 1, 2, and 3. Highest degree is 3, so we call that a cubic. And 3 terms, tri meaning 3, trinomial. So you want to be able to classify by degree and by terms, and then keep those straight in your mind. That's going to be the hard part. Some of you will struggle with that possibly. Yeah?
For the name using the number of terms, would that be after simplifying it?
After simplifying, yeah. Yeah, good question. After simplifying, you would classify by number of terms. Okay, so let's say we had one that was like x cubed plus 2x minus 5 plus 5, let's make that an x squared, 5x plus 7. So now I have 4 terms. 4 terms we call a polynomial. With 4 terms. We're not going to go any more specific there. Polynomial with 4 terms. All right? And this would still be a, by degree, it would still be a cubic. Or if we say we had like an x to the 4th, if it was a 4th degree, we would just call it a 4th degree. 5th degree, we call it a 5th degree. Okay, so let's say I have x to the 4th. That's a 4th degree monomial. Okay. Any questions there? So after 3rd degree and 3 terms, we go pretty generic. Okay, let's see if you can classify these here. There you go. Okay, so here we go. First one by terms. 2 terms is a?
2 chains.
We can't simplify it, so binomial. 2nd degree? Quadratic. Okay. Letter B, one term is? Monomial. And 3rd? Cubic. And letter C, 3 term? Trinomial. And degree is? Quadratic.
Can you just write it as quadratic binomial?
Sure. Yeah, you could call it a quadratic binomial, cubic monomial, quadratic trinomial. That's usually how you'd see it. Usually the other way. Any questions there? That's what you're going to be doing today. So before we dive into our assignment, I want to give a go on one of these problems. So everyone will need a graphing calculator. We'll talk a bit about cubic regression. Grab a graphing calculator. Okay, so this problem, find a cubic function to model the data below. And then really pay close attention to this hint here. Hint, 1968 is equal to 0. That means in this story problem, 1968 is when the time began. Okay, so rather than having 68, we actually have year 0. Okay, which means 1969 is year
1.
and 70 is,
2.
and 71, and 72,
Oh,
and 76,
8.
and 80,
16.
12.
12.
and 84,
50.
and 88, and 92, and 94,
26.
and now you'll notice it doesn't just jump to 96 because this book this book is so old that they pulled these stats from a 96 almanac, so they didn't have the year 96 in there. That was the copyright, I know. Sorry. So this is our x, this is our y. Why don't you remind your neighbor how to put a list into your calculator?
Calculator.
Okay, how do we put a list into a calculator? What are we pushing? Yep.
Stat.
Stat. So we go to stat right here. We hit it. What are we selecting now?
Edit.
Edit. Now last period when I did this, my calculator wasn't in the correct language. That made it a little more challenging. But you notice I have mine in there. There's all my data. Okay. I've got list 1 is x, list 2 is y. Notice I have the same number of values in each list. So you guys go ahead and enter that data into your list. Go ahead and check out your list. Make sure that your list matches mine. Just so that we don't have any big mess ups here in a minute and you're like, oh man, that's why it didn't work out. Okay? Well, letter B. Letter B says estimate the record in 1998 using the cubic function as a model. 1998 is year what?
30.
Year 1998 is year 30. All right, 1998. Well, first I guess we have to find the cubic model. The cubic model would be our cubic function model would be our equation. So we have f of x equals, and then we have this big cubic. Now we actually have to figure out what that cubic is. Using our calculator, we could come up with cubic regression. Now, does anyone remember how to do regression equations? Trent?
You go to stat.
Stat?
Calculate.
Calc, so over to calc. In this case, yeah, it's number 6 on mine, the cubic regression, so option 6. And then it says, what list do you want to use? List 1? Sure. That was our x. List 2 was our y. Don't have to worry about those other two. And then calculate, we have this big mess. In the form of ax cubed plus bx squared plus cx plus d, which is our standard form for a cubic, our a is that. So what I'm going to do is we're going to round to the nearest hundredth. So go ahead and write out your function to the nearest hundredth. So those of you that have an r squared down here, that's our diagnostic tool. If your r squared's closer to 1, then it means it's an exact match on that stat plot. If it's further away from 1, then it's less of a match. But it has nothing to do with the equation. Yeah. All right, so I have 0.02 x cubed. Looks like it's going to be minus 0.72 x squared plus 6.75 x plus 98.19. Good? Tell your neighbor how you could figure out what our record would be in 1998. How could we predict it for letter B?
Plug in for x. 19 or 30.
Okay, so rather than, other than just like going to Google right now and looking, which would be the obvious route since we're in 2014, how could you predict using this data? Yeah.
Plug in 30 for x.
Good. We could just plug in 30 for x. Now, we've rounded here, right? So it's not going to be an exact. Okay? How could we use our calculator to do that without plugging it in? Cody?
We could graph it.
You could graph it. So let's go ahead and graph it. Go y equals. But now we have to put all that mess into our y equals editor there. How do we do that?
Copy and paste.
Well, it'd be nice if we had a copy and paste option. Now, we've done this a bit earlier. Yeah?
Go to vars.
Go to vars. Yeah, we're going to click in the y equals. Make sure you're here. Hit vars.
And then you go down to statistics.
Go down to option 5, statistics.
And then you arrowed it over to EQ
Over to EQ.
and number 1.
Option 1, regression equation. It'll take the last regression equation you had. Well done, Cody. Okay, how many recall that from earlier in the year? We've talked about it before. Okay, hopefully some of you wrote it down somewhere. If not, hopefully you'll take notes on it. We won't do it too many more times this year. Yeah?
What do you do after going to EQ?
So you go to stat, calc, stat, excuse me. Where are we at here?
You just go to, there's a vars button.
Oh, excuse me, that's what I need to do. So go to vars. Go vars, and then stat, and then option, or EQ and option 1. Okay, so you should have a big mess in there. Now, last period I had some students that had the old operating system on there, so it messed it up. If you still have the old operating system on your 84 calculator, it's not going to work. Okay, so you'll know that here in a minute. So now, would we use the graph for this? Like when you're making predictions, are you using your graph?
No. You're using a table.
Yeah, probably want to use a table. So let's everyone go to our table. Okay, now the deal is I get to my, oops. I didn't want my graph. All right, when I get to my table, if I can get to my table.
It's loading. There we go.
There we go. When I get to my table, if I don't want to go through the painstaking task of scrolling all the way to 30, how could I start my table at 30? 30?
Mine doesn't show that.
Didn't work. Yeah?
You could do second window, which is table set.
Good. Second window, which is table set. Well done. And it tells you where do you want to start. We'll start at 30. Now we go back to the table. There we go. We started at 30. So I have 164.62. 164.62. Okay, now that's seconds. Do you think that estimate is reasonable? Yes, no, why not? I'm going to talk with your neighbor about it. So yeah, that's what I heard earlier today. Like last period, I heard 2 or 3 students, my calculator's broken, it doesn't work, it's broken, I can't figure it out. Okay, there's a couple problems usually when your calculator's broken. A, you got the wrong operating system. B, most common, user error. Okay, so that just means you need to get help, and I can help you out, but for now, follow along on your neighbor's calculator. Who says yes? Good estimate. Who says no? Not a good estimate. Okay, I would agree, no. And really, cubics are not good for extending data. Okay, does anyone know what a cubic graph looks like? Yeah, it's like a squiggly line. Where does it usually start, Sam? Like where at in here? Top right, bottom left, top left?
Bottom left.
Bottom left. Starts down here. Let's say we're just going to do a basic one. It's not this one. Say it goes through the origin, then where does it go?
It curves the opposite way.
Yeah, it goes top right. And so now if we're graphing time here in terms of, years here, and time here, now I hope that everyone's paying attention because this is when you actually apply this stuff a little more. Okay? When you're going years and time, put that away or I'm throwing it away. Okay? Years and time, this right here, if I'm saying 1994, notice if I go out to 96, 98, and I keep going, my time just keeps increasing. That means I am not getting better at all in time. You'll never get a lower time based upon a model prediction like this. Okay? What ends up happening is if we add more times and times go down, then eventually we get a different model. Okay, which could be a quartic or 5th degree or 6th degree or 7th degree. Okay? A cubic will never come back down, so it's really not good for prediction. Okay, it's good for certain things, and if you have a different type of cubic model, you could have a cubic model that does something like that. These maximum and minimums, or well, actually that wouldn't work either. So, anyway, we'll get into that. We'll get into more of those here in a while. Your first problem tonight's like this, though. So right now, I want you to make sure that you understand what's going on. Talk to your neighbors about it, and try to get any calculator stuff hammered out as I'm walking around handing out your assignments. So on the assignment, if you turn it over to the other side, your first problem I want you working on is number 22 here. similar problem. I want year 1950 to equal 0 here. Okay, so set that equal to 0. All right. The rest of your assignment is the bottom portion of this. So you're only doing the back side of this. The front side you're not doing anything on. You're not allowed to cross it out though, because we're going to use that tomorrow. Just the front side, or excuse me, just the back side here. Okay. So 22 through 37 is your assignment. Those of you that need your calculator upgraded, you're going to have to talk to me about it here in a few minutes, and I'll try to get them plugged in for you. Yeah? You didn't get one? All right.